difficult versions of them. Okay, and we're going to use the fundamental principle of multiplication and addition to solve them also. Okay, so let's see how many three letter words can be formed from these letters we have. One, when repetition is allowed. Second, when repetition is not allowed. So see, repetition allowed means that it can be a, but in case of repetition not allowed, then it cannot be a b. So this is not allowed because a is repeated. It can be like this, abc or bac, like that. So no option of repetition is there. So the way of solving it is very simple. Draw this like this. So these are the three letter words. I have five options. First, let's look at when repetition is allowed. So, okay, the first letter could be any of the five. So, I have five ways of filling the first space. Second letter, since repetition is allowed, again, I have five options. So, I can write five. Third letter, same. I have five options, so I can write five. See, it can be any of these five letters, A, B, C, D, E, any of the five. Okay. So now five ways of selecting first, five ways of selecting second, five ways of selecting third. Just simply multiply, get 5 to the power 3, which is 125. Okay. Second one, please don't forget to write the statements. The second one is when repetition is not allowed. It means if A I have selected, then I cannot select A here, I cannot select A here. And if I select B over here, I cannot select even B over here. So the thing is, again, this is also very simple. First letter, I can choose from any of these five. So I have five options. After I've chosen one letter, I am only left with four options. So four. Okay, four. So there are four ways of selecting the second letter. The third letter can be selected because see, one letter is already used, another is already used. So I am left with only three letters. So three. That means it is 5 into 4 into 3, which is 60. So 60 is my answer for this one. If repetition is not allowed, then I can form 60 three letter words. If repetition is allowed, then I can form 125 three letter words. It doesn't matter if it has meaning or not. Okay, next, move on to the next question. Find the number of different signals that can be generated by arranging at least two flags in order, one above another. See, like this, I have to generate. These are the two flags. Okay. On a vertical staff, if five different flags are available. So, understand this question. They are saying, I have five flags. Okay. I have five flags and I have to make like this. I have to make arrangements. So I can select any two. Okay. And I have to make like this arrangements. So how many such arrangements I can form? Very simple. This is also, see, two and I have to be generated by arranging at least two flags. Now here, what a lot of students will do is that, okay, so I have to arrange two flags. So here are my two flags. The first flag can be arranged in five number of ways, so five. Second flag can be arranged, the second one which is on top of this can be arranged in four number of ways because one is already used and we have total five. So 5 into 4 is equals to 20. Done. That is wrong. This is half done because here we have an at least sign, at least two flags. So at least two flags means it can also be three flags, it can also be four flags, it can also be five flags. So I can either take two flags or three or four or five. Okay. So now it's again very simple. You don't have to do anything. If I am making a combination of three flags of different signals, different means they have to be distinct so they can't be repeated. So then I have 5 into 4 into 3. What is 5 into 5 into 4? So this is 60. If I will make four flags like 1 2, so again I have to choose 1 2 3 4 different signals. So now four flags, right? So 5 4 3 2, we are using the same mechanism over here, so this becomes 120. And now if I'm selecting all five flags, so that means 5 into 4 into 3, the third, so see, if I'm selecting all five, so this can be selected in five ways. The second, I have four left. The third, I have three left, like that. Okay. 3 into 2 into 1, that is again 120. So now, okay, now see, all of this I'm going to add. Why add? Because see, it is written how many signals can be generated by arranging at least two flags. So I can use either two flags or three flags. Okay, I can also use four flags or five flags. So here there is or, since there is at least, so or or, and these are the number of ways. 22 flags I can do, or I can do 63 flags. But if I'm doing two flags, I will not do three flags also, right? So that's, so because there is an or, we add them. So 0, 2 plus 2, 4, 4 plus 6, 10, then 2, then 1, then 3. So the answer is 320. Let's look at the other next question. How many six digit numbers can be formed by using the digits 0, 1, 2, 3 like this when no digit is repeated? How many of them are divisible by 10? This is a very interesting question. This is also very important. So, first, see, we need to form six digit numbers and we have been given six digits. So, let's write like this: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so we have also six options. So the first place can be selected by any of these six digits, right? So I'll write 6. Wrong. This is wrong. Why? Because you cannot put 0 in this place, in the first place. See, ones, tens, hundreds, thousand, 10,000, lakh. Okay, you cannot put 6 in the lakhs place. You cannot put 0 in the lakhs place, because then it will become a five digit number. So this is wrong. This is the correct one. C. 1, 2, 3, 4, 5, 6. The first place can be selected by any of these five digits. 0 cannot be selected. So we'll write 5, because five ways in which we can fill the first place of the six digit. Because 0 cannot be. So I have only five options. Second one. Now, out of this one, 0, 1, 3, 5, 7, and 9, one digit has already been used. Maybe let's say one is being used. So the total options left are 5. Now I can use 0. So again I'll write 5. Now see, one digit has been used, another also has been used. So the number of options left, it's 4, then 3, then 2, and then whatever is left at last, it's only 1. So I'm going to multiply by. This is going to be your answer. So let's see. 25 times 4 is 100, times 6, 600. So 600 is my answer. Now look at this. A very interesting question they are asking. How many of them are divisible by 10? So I'm using another style. So a number to be divisible by 10, what is the condition? The last digit of that number should be 0. Okay. So see, this is any six digit number that we form using 1, 3, 5, 7, 9, and 0. So this place has to be 0. Okay. So let me fix 0 over here. Then what do I have? These five places. The 0 is already used, so I will not use 0 again. I have these digits. Now understand, these digits: 1, 3, 5, 7, 9. I will make different arrangements of this digit over here to get six digit numbers, right? And these are the total arrangements in which 0 is in the ones place. So all these numbers are going to be those numbers that are divisible by 10. So, first, I have to arrange these digits, and repetition is not allowed. Okay. So, this can be done in 5, into 4, into 3, into 2, into 1. By now, you should know why I have written this, because one digit I will use, then I have four options left. So, like this. So, this is 120. So out of all these 600 numbers, there are 120 numbers in which 0 is in the last place. Okay. And all these numbers are different arrangements of the remaining digits that I have. That is, the total number is 120. So now suppose in the question, if it was given how many of them are not divisible by 10, then what you would have done? You would have subtracted 120 from 600 to remove those numbers, those arrangements where 0 is in the last place. See, this is also, there are total 6 digit numbers. Okay, this is how we solve this kind of sums. All right, so 120 is the answer of the second part of the question. Thank you guys so much for watching this video.